Welcome to the new episode of Technology and Electronics News. I'm your host, Pavel Yankovich, bringing you the latest updates from the world of hardware, and let's explore together. TrendForce's top tech trends for 2025 reveal a few interesting forecasts. Humanoid robots are finally going to mass production, with a stunning 154% annual growth rate and $2 billion in revenue by 2027. AI notebooks will become mainstream, reaching 21.7% penetration by the end of 2025. And AI servers surge, with shipments growing 42% in 2024 and 28% in 2025. Advanced chip making is evolving as TSMC, Samsung, and Intel compete to lead in gate-all-around technology at smaller nodes. Meanwhile, CubeSats are driving low-cost satellite constellations for global IoT and communication, while tackling space leader. On the display front, AMOLED panels are going to be expanding into tablets and notebooks, with a projected market of 6 million units by 2025. AR and VR devices like Apple's Vision Pro are pivoting to productivity tools, with near-eye display tech leading the way. Lastly, battery innovation is accelerating, with semi-solid-state batteries set for 2024 and AI data centers pushing demand for next-gen energy storage. As you can see, 2025 is shaping up to be transformative. The semiconductor trade battle between the U.S. and Asia is escalating, with new restrictions and responses reshaping the industry. The Biden administration is reportedly planning sanctions on 200 more Chinese chips firms and tighter control on high-bandwidth memory exports. These moves aim to slow China's chip advancements, particularly in AI, as domestic firms like SMIC struggle to leap beyond 7nm technology without extreme ultraviolet equipment from ASML. In response, China warns of necessary actions to protect its tech companies. The tension has already affected global companies like ASML, whose shares rose after reports suggested restrictions may be less severe than expected. Meanwhile, TSMC faces its own challenges. Taiwanese officials clarified that transferring leading-edge 2nm process to overseas fabs, including in the US, is restricted by local laws. As TSMC ramps up its US facility with older nodes, political pressure, including potential tariffs under a Trump administration, could actually force earlier transfers of advanced tech to Arizona's Fab 21. AMD's new patent brings glass core substrates closer to reality. Unlike traditional organic materials, glass made from borosilicate or fused silica is ultra-flat, thermally stable, and ideal for dense, high-performance chips like data center processors. The patent details through-glass vias, tiny pathways for data and power, created using advanced laser drilling and magnetic self-assembly. AMD also replaces solder bumps with copper bonding for stronger, gap-free connections, perfect for stacking multiple glass layers. With rivals, Intel and Samsung exploring glass tech, AMD's patent secures its lead. Glass processors promise better heat management, durability, and performance. Is it the future of chips? Clear as glass. Intel is at a critical crossroads, navigating government contracts, major funding, and industry challenges. The company secured $7.86 billion in CHIPS Act funding, down from $8.5 billion, along with $11 billion in loans. These funds come with strict rules. Intel must maintain at least 50.1% ownership of its Intel Foundry unit, even if sold out, and must spend $35 billion on the US R&D, while building 12 fabs across Arizona, New Mexico, Ohio, and Oregon. Despite these efforts, Intel is facing scrutiny over its process technology. Trailing TSMC and struggling to convince customers it can reclaim its edge with innovations like 18A nodes. Meanwhile, a potential acquisition by Qualcomm fell apart due to complexity and regulatory hurdles. Qualcomm explored buying Intel directly or parts of its business, but stepped back, leaving Intel to restructure and focus on retaining its market share. Intel CEO Pat Gelsinger remains optimistic, emphasizing American-designed chips and the importance of domestic manufacturing for economic and national security. However, the company's challenges, including dropping market share and hard competition from AMD and TSMC, underscore the tough road ahead. SK Hynix just launched the world's first 321-layer NAND memory, a triple-level cell 40 NAND with 1 terabit capacity. It's faster too, with 12% better write speed and 13% faster reads than its 238-layer predecessor. The breakthrough comes from Hynix 3-Plux process technology, using low-stress materials and auto-alignment to stack over 300 layers. Plus, they have boosted productivity by 59% using the same platform as before. Mass production is underway, with products shipping early next year. Germany and South Korea are willing to juice up their own chip industries. Germany plans up to 2 billion euros in subsidies to boost advanced chips production under the European Chips Act, aiming to cut reliance on Asian supplies. Meanwhile, South Korea is rolling out $10 billion in low-interest loans to support its chip makers and build the world's largest high-tech chip cluster. With growing competition from China, both nations are racing to secure their place in the semiconductor future. Meta is planning a $10 billion Subsea cable spanning 40,000 kilometers to connect the U.S., South Africa, India, and Australia. This ambitious project aims to boost infrastructure for Meta's platforms, which drive 10% of fixed and 22% of global mobile traffic. Why do they need it? Sole ownership ensures control over data traffic, avoids geopolitical risks, and improves service in key markets like India, where Meta has over 500 million WhatsApp users. The project, still in early stages, will support Meta's growing AI and data needs, with more details expected in 2025. Those are the main updates we have for today. Thank you for joining us on Technology and Electronics News. See you in the next episode.